I did nothing.
Oh, you know what you did.
I did nothing.
I don't know what he did.
I know
I'm sure
I
it was
did
bad.
nothing.
I'm sure it's bad. Whatever he did. Was it cal or pre-cal?
Calculus.
Ugh.
Yeah.
Oh, well, I probably should have said that right in front of Scott, but whatever.
I think it
You guys get the same memes as we do?
No, we got different ones.
Oh, you guys are special.
Yeah.
Last year, I probably.
We get the best ones. The armies are way better than that.
Yeah, that's really, that's kind of, those are like algorithms or magic or whatever. You know?
Yeah, exactly.
Yeah, exactly.
Dark sorcery.
That's what I'm saying.
I agree. That's like the realistic thing I've ever seen.
Really?
Now this just looks weird. I mean, I feel like I just feel like I'm in the wrong place right now.
Give it
No,
60 seconds. And I'm going to post in Google Classroom what the homework is.
we're the only people here who are, we're the only people here. No, we aren't.
I have a question.
Yes.
You put a 4 out of 8 for the Khan Academy thing, but it says it's not due until tomorrow morning.
I don't go by that due date.
When was it due?
Before class
Oh, I
today.
know I didn't get the
That's what I said in class.
I wasn't here on Monday.
It was in the class recording.
I didn't want to. Well, can I still get points for some of it I have to do tonight? Because I didn't have time to do
You can
it.
always get half the points back if it's done before the test. Yeah, I don't set the Khan Academy ones because I have 2 different classes, and then if someone's absent, then they don't see it, and so I have to push it out. So it doesn't work like that.
I don't think fair people solve gets it from last time I checked. Why? Well,
I can't believe for like half an hour sitting there struggling from success.
yes, I why am I crying? When?
I knew that I was working when you made them up from podcast
I never
on
opened
the brain
this.
on the incident kind
All summers. If that Elder's there, where's it going? Oh. Remember I told you the P1S was right there on, you know, the mask of the P1S, it's people, right? That's, you're saying the mascot for P1S is not a people. It's the same kind of people. It's like the mascot for Razorbacks is not that specific Razorback. It's not that specific ball. It's just a hard joke.
What happened? Do you know what happened this week?
Another thing about it, do they still have
You mean the fire drill?
It was a drill.
The statue.
Well, it was supposed to be a drill, like we had a drill scheduled for this afternoon, but that was not the drill, so
So is that gonna be our?
Why is my back like
it should count as, yeah, we have to do 1 a month, so that should count as our 1 a month.
But if that wasn't a drill,
Well, but it still got treated as a drill. It should be fine.
okay.
What?
Luckily I was gone. So I was scared. Every time I
Oh.
said I did like.
So we have the other one? You should have that one.
I was like, why are there so many?
Good. Don't you want to like skip English? Do you really want English? Like I said, somehow the shortest class is also the longest class in multiple ways. But it's also the longest class. It feels long. It literally is long. It's like saying, okay, if
Okay, I know we're halfway waiting for everyone to finish up with the drill. However, it does look like we have a bunch of people out for school business, so we might actually not be waiting on anybody here. So give me just a second to be sure.
Okay, imagine getting paid. Imagine getting paid $100
Business.
a week. And then also imagine you getting paid $20 a day. Now, they're the same, right? No, sorry, on the weekdays. It's the same, but it feels like you're getting paid more when you're getting paid $20 a day, because that's increments of days, whereas you're waiting for a week to get paid $100.
Call Jake.
Literally, I mean, like physically, it's the same, but mentally, it's not.
No, I get it.
That's what I'm saying. I don't know what real deal it is.
Okay, everybody that's supposed to be here is here except for maybe one.
We can just not.
So let's go ahead and get started here. So last class we did 3.3, which was on expanding and condensing. And now we've gone into the last section, logarithmic section. So we'll spend 2 class periods on this, where we'll have some time to review those two together, and then we'll quiz them, and then test them, and then we'll be finished with logarithms from the year, and we can do some other algebra thing. But just a heads up, basically all of the properties that we learn about logarithms, the whole reason we spend time in Algebra 2 and pre-calculus, and it shows up on the ACT and all that kind of stuff, is really for what we are going to be doing today. If logarithms did not do what we're going to be trying today, they just wouldn't be very important, and they wouldn't be such a big part of math curriculum. So a lot of what we've been doing has really been trying to build up to this. So our focus in this 3.4 is solving equations. And to be fair, some of these can be pretty tough. So our notes are very detailed this time, and they start us off about as easy as possible, and then slowly works us up to where we can do the hard ones with the same skills. So you'll want to make sure that you give a little bit extra focus with the notes than normal. All right, so what makes logarithms unique and special? What can they do algebraically that nothing else can do? That is solve exponential equations. Anytime you have a variable that's stuck in the exponent, if you need to solve for that variable, you have to use logarithms. With one exception. The one exception would be if you can do it in your head. So the first little section here is if it's easy enough that you can just do the one step in your head, then of course take the easy route. So 5 to what power gives us 25?
7.
Okay, 2 to what power gives us 16?
5.
That would be 8. 2 to the 4th gives us 16. And I don't really consider this a log property, but I don't know, maybe you do. Just being able to read a logarithm. 2 to the 3rd gives you 8. 3 squared gives us 9. So some of the questions will be that straightforward. But of course they can't all be that easy. They're not all nice whole numbers that we can just quickly do in our head. But always try that first, because that's going to be the easiest. Okay, the main one that you're going to get sick of me saying today is switching forms. So in 6 through 8, we're going to talk about if they're in exponential form, you should consider switching them to logarithmic form. So remember, that just means put log out front and swap the correct two things around. Put log out front and swap the correct two things around. The reason we already had you practice switching forms is not because switching forms is all that important for anything except for solving equations. If you can switch the form and you get x equals, x equals, x equals, that's the solution to those 3 equations. Now, the only one that bothers me a little bit, technically this is correct on number 6, but you should probably make a habit, instead of leaving an answer log base E, you should probably change that to natural log. They mean the same thing, but if you do this, people are going to think that you don't really know what you're doing with logarithms. Everybody changes that to natural log. So this is going to be one of the most important things. This is going to show up in practically every question we do today. Now, over to the right, I have the same 3 questions, and so I'm going to get the same 3 answers, but I need you to know that there's an alternate way to do this, and I'm showing this to you for 2 reasons. One is you may prefer this method, which is fine, and 2, sometimes this is your only choice. So when we get to the book assignment and you're practicing some questions, if it doesn't seem like it fits any of the other types, it could be that you need to try this. So in mathematics, we can take the log of both sides, or the natural log if you prefer. I always do natural log because that's what we do in calculus. But that's okay to do because I'm keeping my equation balanced. I did the same thing to both sides. The reason that this technique can help you solve the equation is now because of log properties. X is an exponent on something I'm taking the log of, so that can come down out front. And what is natural log of E? 1. So x times 1 is just x, so the answer is natural log of 5. Notice, same answer. I'm not saying that this is an easier approach, I'm showing you that it also works. And sometimes you can't switch the forms, sometimes all you can do is take the log of both sides. I know there's at least one book question where that's the only thing you can do to get it started. So once again, you could take the log of both sides or the natural log of both sides, whatever you prefer. It's going to make your answers look different, and in fact that's one thing we'll talk about before this assignment's over. A lot of the answers to these questions are going to look very unusual, and normally I would say it's a sign that you did something wrong for your answers to be that crazy, but we can check them with the calculator. And again, that's important because on a question like this, if I had taken the log of both sides instead of the natural log, my answer would look quite a bit different, and it could still be correct. So, all right, so same thing, log of both sides. So then you can do this exponent property. This can come down out front, and then you can undo times with divide. Get it down to x equals. Now again, just to kind of confirm what I was saying, notice these two look quite a bit different, but you should actually know that these two are the same. Why should I be able to expect you to know that log base 10 of 3 is the same thing as natural log of 3 over natural log of 10? Right, if you know change of base, then you know those two things are the same. So, all right, and then one last example. Take the log of both sides so that the thing you're solving for is a variable on something that you're taking the log of. That way you can bring it down, and then you can undo times with divide. Again, this is not a common method, but sometimes you need it. So just a tool that we need to consider when nothing else works. Same thing, 11 and 8 look different, but if you know change of base, you can already tell that they're the same thing. They look different, but they're exactly equivalent. Okay, so if switching from exponential form to logarithmic form is going to be a common one, then going the other direction is also going to be a common step. So that's what we're going to do in these 4. If it's in logarithmic form, you could try to switch it to exponential form. Remember, natural log means log base E, so feel free to change that if you want to, but switch it from logarithmic form to exponential form. Notice you could spend all day and you're never going to guess the answer. E to the -7th would be the answer to that, at least just from guessing. But by just switching from logarithmic to exponential, it was already done. Over here, switch it to exponential form, and at least it looks a way that is familiar to me. Logarithmic form, to exponential form, and then it's solved. Now again, I'm not going to dwell on this too much, but if you don't understand where this e is coming from, if you can't see that without writing this out, you need to add one step to all of your work. Natural log just means log base e. Make yourself write that step out, because that is where the e is coming from. Okay, so just summarize what we've talked about thus far. Occasionally, you can just do the questions in your head, so do that if possible. Most questions, you're going to have to switch from exponential form to logarithmic form, or logarithmic form to exponential form. And then one of the worst case scenarios, if nothing else seems to work, try taking the log of both sides. Okay, so now to start building up the difficulty, we can still switch the forms of 16 through 19, but you're going to see that we don't know what x is when we do that. So on 16, if I switch the form to exponential, I'm not quite finished because I don't know what x equals. I know what 2x minus 1 equals. But the hard part should be finished, because you know how to undo a minus 1 and you know how to undo a times 2. So that's what I mean by basic steps of algebra. Just undoing, add, subtract, multiply, or divide. So if I switch the form, then I could undo a times 3 with the divide by 3. Again, answer looks kind of crazy, but that's just how most of these go. So if it's in exponential or logarithmic form, switch the form. If you have x equals, great, circle your answer. If you don't have x equals, do your normal solving stuff, like multiply both sides by -1, or undo +7 with the -7. Makes the questions a little bit longer, but it's not logarithmic based, so you should be okay with that. Likewise, sometimes you need to undo some basic algebra before you can switch the forms. So if you look at questions 20 through 23, those are not in logarithmic form and they're not in exponential form. But if I was willing to undo a +9 from both sides, or if I was willing to undo a ×2 from both sides, or undo a +5, or undo a ×7, now they're in exponential or logarithmic form, so we can finish them just like we did a couple sections ago. Switch the form, and you might be done. Switch the form. If you know what x equals, then you're finished. Switch the form, solve for x equals. Switch the form, solve for x equals. So that's why I said that you're going to get sick of me saying that one today, because even on these harder questions, harder in that you have to do more steps, I still switch the forms in questions 16 through 23. 16 through 19, I did it at the end of the question, the basic algebra at the end of the question. 20 through 23, I had to undo the basic algebra before I could switch the forms. Then 24 and 25 is combining both of those. We're going to have to undo some basic algebra at the start and end of the question, and sandwiched in between those is going to be switching the forms. So the way that you should know that you're not ready to switch this form is that it's not exponential form. This 2 is in the way. Over here, this 4 is in the way. Bless you. So sometimes you have to undo, add, subtract, multiply, or divide just to get it in logarithmic form or exponential form. Then, like 90% of these questions, the main trick is going to be switch the form, and on some of the harder questions, just because you undid add, subtract, multiply, or divide at the start of the question, you might still need to undo add, subtract, multiply, or divide at the end of the question. But that's just normal solving stuff, so I don't think that's going to be a problem for you. But you just need to structure it that way in your head. You know you need to be aiming to switch the forms most of the time. So if it's not in the form, try to get it there. After you switch the form, if you don't know what x equals, then do what you need to do to get it to x equals. Yeah.
On like 25 and 23, does it matter that you put log instead of natural log if it has a mean?
Mathematically, they mean the exact same thing, but you really should make a habit out of saying natural log.
Isn't 23 just normal one?
Yes, it was. I just went too quickly here, sorry. This would be log of x is 1, so 10 to the first is x, or x is 10. Thank you. I was probably looking at something else. Okay, so that's what probably the majority of the questions are going to be like. Switch the forms, maybe undo, add, subtract, multiply, or divide at the start, end, or both. But on to the back page, there's a couple other little things, not common questions, but things you need to be able to do. 29 doesn't fit this. You can cross that one off. I should have crossed it off. But if you look at 26, 27, 28, nothing that we talked about on the front page applies here. I can't do any of these in my head. There's not any basic add, subtract, multiply, or divide I could do, and they're not in logarithmic form or exponential form ready for me to switch. So that's how I know nothing on the front page helps me with these three questions. But what we learned in section 3.3, expanding and condensing, opens the door to us solving some more questions. In fact, I did one of these in your 3.3 notes just to show you one reason why you need to be able to expand and condense. So you could condense these into log base 2 of 5x. And as long as you can condense here and you consider condensing, now it's not any harder than any of the questions on the front page. Switch the form. Undo times 5. Okay, I've got the same issue with 27. None of the other stuff I've talked about works, but because I can condense these two into a single logarithm, that puts it in logarithmic form, and now I can switch the forms and undo a divided by 3 with a multiply by 3. And those are the only two ways to condense. Addition condenses to multiplication, subtraction condenses to division. Okay, and then just one more for a little more practice here. Addition can condense to multiplication. And that's helpful because now it fits logarithmic form. We can switch it to exponential form and undo times 7 with divide by 7. So this one's not as common. I'd be very surprised if it's not on your next quiz and test. But you need to just have this as a tool. When nothing else seems to work, question yourself, is it something I could expand or condense? Because if so, that might be the key to moving forward. Okay, a few of the questions get mixed in from what we did in section 3.2. So in 3.2 we did some solving equation stuff, but they were just real basic ones. So some of those basic ones still show up. And by basic, I mean like this is log base 2, and this is log base 2. So to make sure these are equal, I just need to make sure that x plus 7 is the same thing as 5. Now, technically, you should want to plug it in to make sure that it does make the left and the right side the same, but also it's important for checking for extraneous solutions. Your answer can be 0 and your answer can be negative, but you can't take the log of 0 and you can't take the log of a negative. Plugging in -2 makes me take the log of 5 on both sides. There's nothing wrong with that. Or maybe like over here, this is one of those log properties, 5 to the log base 5 of 8. If you know that property, all that becomes 8, then you're left with an algebra 1 equation to solve. So you already practiced some of that. I realize you might feel a little rusty because it was before spring break, but those are on the easier side. So, but a few of your questions are like that. Okay, and then finally, the last one that just kind of fits a little different pattern is number 32. So again, this is not something I think of on every single question, but thinking about what the structure of the front page says, I obviously can't do this in my head. It's not an exponential or logarithmic form to switch. There's no add, subtract, multiply, or divide that I could start off by undoing. I can't expand or condense my logarithms. There's very little that I can do. But if you've got 3 terms like this, these are set up to work out by factoring. So you can either do guess and check. E to the x times e to the x gives me e to the 2x. When you multiply things with the same base, you add the exponents. I could do a -4 times a -1 to get a +4. And when I FOIL, the outer and inner combine to -5 e to the x. Now, if you don't want to do guess and check, that product sum method that we practiced last semester also works. Even with the e stuff, product sum would still work out just fine. And then when you have 2 factors that equal 0, it could be that this equals 0 or this equals 0. So just like when you solve quadratics this way, you might get some answers from both sides. And then here's where the front page comes back in handy again. Both of these are exponential form. Both of them could switch to logarithmic form. Again, try not to say natural log of e, I'm sorry, log base e, just say natural log if possible. And then what about this? Instead of calling this natural log of 1, what would be a better answer? 0. E to the 0 gives you 1, so that's a little cleaner looking. But the main thing is, again, you think of all the common stuff to do, nothing seems to work, but if it looks like this, it might be that you need to factor it. Not a common question type, but that's a tool that you need to have, so you at least know how to start those questions. Okay, so before I recap all of this for the 20th time, or it feels like the 20th time, I want to show you one real life example where it's not just some abstract equation where you would maybe care to do this, although, I mean, it's basically a made-up question. I'm going to talk about how you can know if your answers are correct, no matter how different they might be than your neighbor, no matter how different they might be than the back of the book, no matter how crazy the answer might look. I need to make sure that you know how to check your answers. And in fact, a lot of the questions we pick out for this book assignment are specifically even questions, not because I'm not trying to get you to use the back of the book. Just having the back of the book answers, I mean, you'd have to have the work to go with them anyway, so I'm not worried about that. But by making them even, it forces you to check in your calculator like I'll show you in just a second. Okay, so back in section 3.1, we talked about some compound interest formulas like PERT. PERT was the compounded continuously one. And in section 3.1, we said, well, the starting amount, whether it's a loan or investment, is what is referred to as principal. E is a number, not a variable. R is the rate, and it needs to be entered in as a decimal. And then here's where it's different than what we did in section 3.1. We would have said, hey, well, how much is your investment worth if you save this for 10 years? And you plug 10 in for T, and you would solve for the amount. But that's not always realistic. A lot of times you guys know how much money you have. You go to the bank, they'll tell you what percentage they'll give you. You know what you're saving up for. So in this fake question, we're saving up for a $6,000 car. What you don't know is how long am I going to have to wait? I don't know what the time is. Now again, I don't know that you would need to know exactly what the time is, but if you guys become engineers and stuff, then you need to be able to do this very accurately. But we can do this like we did the front page. I can undo the basic stuff, like undo timesing by 2000. I switch these two just because I think you see this easier. This is exponential form, so we could try to switch it to logarithmic form. And then really the only other step is to undo multiplication a second time. So if you needed to know the exact amount of time you would have to wait for your $2,000 to sit in the bank and grow to $6,000 so you could go buy your car, well, 2% is not much. So any guesses on how long you're going to have to wait? About 55 years. So if that's your plan to get a car, you better get some more money. Sitting there waiting for that 2% interest to grow it to 6% to 6,000, it's going to take you a long time. Again, just a silly example, but it shows you sometimes you care about solving for variables in the exponent, and if it needs to be accurate to 8 or 9 decimal places, like it would be expected of you if you're building stuff for companies and there's money involved, and your boss is going to fire you if you're wasteful or all that kind of stuff, then you need to be able to solve for it exactly. Now, I also want to talk about how to check this. So again, this is a really unusual looking answer, so you shouldn't necessarily feel confident about this. But we can know that this is going to work. And the easiest and best way to do this is to do the store button. So I've shown you the store button before, but I really feel like you need to practice it a handful of times today. So if you type in your answer, no matter how crazy it looks or how different it is than your neighbor or different than the back of the book looks, you can type it in, hit the store button to create this little arrow, and then plug in a variable. Now I usually just use X because this button gives you X right away, but I'm actually going to do alpha 4 to get T. Since I think that was the time of that, it kind of makes sense to store it in for T instead. And what that was supposed to give me is it was supposed to be the number such that 2000 e to the r, when r is 2%, t, if that's really the right amount of time, then what should this equal? Not close to 6,000, it should be exactly 6,000. So again, if you just store whatever your answer is for X or T or whatever you want, and then type it in, if it makes the left side equal to the right side, then you can feel confident in your answer no matter how unusual it looks. And again, we picked out a lot of even questions so that you would have to do that some, because that's important. Odd questions, your answer could still be right and it could still look different than the back of the book, so that causes some unnecessary confusion. Okay, so last thing, I just kind of summarized the thought process of the notes here, but I'm going to do it by looking at the questions, because this is how I think you need to kind of have a flow chart in your head. If you can do them in your head, great, do it that way. If not, you probably need to switch the form from exponential to logarithmic or logarithmic to exponential. Rarely, but sometimes you have to take the log of both sides. Sometimes you might need to undo, add, subtract, multiply, or divide at the end of a question, the beginning of the question, or the end and the beginning of the question before you switch forms or after you switch forms. Sometimes you can't do anything until you expand or condense. Some questions you've seen from 3.2 already, and if it looks like this, you probably should try to factor it. So that's kind of the tools that you need to consider as you go through these questions. Just go in order of what you think is most likely, and that should lead you down the correct path. All right. Is there anything else you would want to get some quick clarification on before we move on? Okay, then go ahead and get out a blank piece of paper and start the first few questions here. As I did the other day, I will give you a little bit of time to get a handful of questions under your belt, and then I'll bug you for a few on the board. Now, this is also a longer assignment like 3.3 was, but not all of these questions are as quick as 3.3. So I need you to spend the rest of class working on this, but if you don't finish this in class, you don't have to worry about it for homework yet. I would say if you feel like you're falling behind everybody else, you probably should, but do a little bit. But this does not have to be finished by Friday, but we want to get as much done as possible. I do know there was a few people in first period that finished it in class, but the majority did not. Okay, so please copy down the assignment so I don't have to leave the screen up. And then about 15 minutes from now, I'll take the first round of questions. Girls, what question are y'all on? I'll take that as number one. just about 15 minutes, so are there a few that I can help with? Everybody's okay so far? Okay, we'll try again in another 10 or 15 minutes. It's been almost 10 minutes already again, so offer to help out with a couple more, or a couple total, because you didn't ask any last time. Everybody still okay? Okay. All right, we'll check back in a bit.
know what x is?
I mean, if that was something that came out to a nice whole number, you should change it to a whole number, but that one's not going to be, so. All right, offering again, question or two that you would like to see worked out.
Could you do 20?
Number 20, sure. Yeah, and 20, just based on first period today, was one of the harder ones. Okay, so just like question 1A, if these bases are already equal, the only other thing you need to make sure that's true to make sure the whole thing is equal is that the exponents are equal. Okay, you okay with that part? Why the exponents have to be the same? Okay. Alright, so then that's going to leave you a quadratic, which sometimes you guys get creative in solving, but always with the quadratic, you should put on one side set equal to 0. And then most of the time, it will solve with factoring. It will always solve with quadratic formula. Typically, I only do quadratic formula if it doesn't factor. It's because quadratic formula is a little bit slower. But quadratic formula is the only one that's always going to work. Now, unfortunate for this question, this one does not factor. There's no way that you can get that to factor. So, you will have to do quadratic formula here. A is 1, B is -1, C is -1. Now, if you don't remember quadratic formula, it's a good review because this is definitely the most important formula you should have gotten out of Algebra 2. And even though it looks like it's going to be kind of bad, we just plug these numbers in where the formula says, and the only simplifying that you can do is 1 plus 4 like that to get 5. And there we go. Looks like there would be 2 answers. Now, I think you might need to use quadratic formula on 1 or 2 other questions. So if you don't feel like you have that memorized, you might want to jot that down to the top of your page so that you can use it as needed. And again, even though this is kind of unusual, I will quickly store this in my calculator and then compare left to right. So I froze the screen so that I could see the numbers there. But here's one of my answers from quadratic formula. This is an approximate. Here's the left side of the equation, right side of the equation, and we can see that that works. So the plus version works. And if you really want to test both of them, quadratic formula has a plus and a minus there. So this should be the other answer. See what that gives you for the left side of the equation. I don't really care what that is, but compared to what it gives you if you plugged it into the right side of the equation, also don't care what it is other than they're the same thing. So both of those, the plus and the minus version there, both worked. So y'all don't need to like stress out about quadratic formula or nothing, but you should practice it as it comes up. Again, I think it comes up in 2 or 3 questions, and there's one of them for you. Most important thing, though, is understanding why I set the exponents equal to each other, how to solve a quadratic, put it all on one side set equal to 0. You can always use quadratic formula, but you should probably try to factor it first, because factoring is usually quicker. Okay, anybody else have another one ready to go?
reset the timer. You guys still have just under 40 minutes, so still a ton of class time. Again, you should get pretty close to finish with this by the end of class, but it's fine if you don't get all the way 100% finished.
that, we might do it just because some people may be bored, because, I mean, I'm trying to think of who knows everything about Delta Math. It'd be Myrick, but he can help other people.
Yeah. I don't know. I mean,
I mean,
I know
we're
that
just
Algebra
gonna-
3 group thinks they know a lot, but they just do assignments. They don't know anything more advanced.
Right.
So
I think we'll just kind of roll with it that way. Kelly, I think, knows quite a bit.
Kelly knows more than most, yeah.
Yeah. So we'll just do, what do you want, 30 minutes? And then, like, I'll just set the timer at that, and then if they got it, they sneak out, and if not, I'll stay.
Yeah, I would just say, I mean, you don't need to tell them 30 minutes, but,
Yeah.
you know, somewhere 25 to 35 minutes.
Should
Just
be
tell
fine.
them that they can do the rest of the hour
Right.
on their
So,
own for homework.
What I'm gonna do is I'm gonna do it live. Like, I'm gonna have everybody join a dummy
Mhm.
Delta Math training, Google Classroom thing, and I'm gonna record it, and then I've got 5 questions, and then we're gonna take a dummy
Yeah.
quiz and show how I implement it, like, as you're taking the test, and, like, you know, the different things there, and then I'll show how to create the corrections, and go through that component, and then do that part, and then we'll examine the data.
Yeah, I would even say the advanced group, I would just let them share with each other. They don't,
Well-
mean, you don't have to do anything there, I don't think.
Well, I was just gonna make them do it to get the data part, but what I was gonna do is just like have them like share out how they use it, or different tips of
Mhm.
like, I messed this one up, this is something you need to be aware of, you know,
Yeah,
things like that. Cause like you can either link it with Google Classroom or not.
yeah.
So I don't know if we'll necessarily need the Promethean board, but it.
Oh,
we-
okay, that's fine. I can always come back down here and get it if you decide
Yeah.
you want it. The
But-
main issue is just, it's not a problem. I can drag you down
Yeah.
there. It's more of hooking up a computer
know,
to it and then getting pulled up
Oh,
and
it
getting
doesn't,
it.
oh, yeah.
It's,
Then forget it.
okay.
I mean, if they want it, then we can ask and then they can help. All right, thank you.
Yep. Is the time? Yep. All right. It's been almost 15 minutes, so hopefully y'all have found another question or two. What you got?
26.
Number 26. Okay, so when I look at 26, it already looks like it's an exponential form. So I'm going to switch it to logarithmic form and hope that that helps. So I put log out front, swap these two things around, and again, a lot of times I just don't know if that's going to be good, but you kind of just have to try something. So this looks like this worked out great, because now all I just need to undo is timesing by -3, and you should be finished there. That should be good. Alright, what else?
38.
38. Oh, 38 is a great one. Now, if you're not already to 38, again, you guys are welcome to skip ahead to it, or you can watch the class recording later, or I should have this one worked out. But this one is a little bit unique in that you go through that whole list of stuff. I'll spare you from saying it all again, but you go through that whole list of stuff, and none of that stuff we talked in the notes helps, except there was one thing I said that you need sometimes. And what you need in this question, the only way to start this question, is by taking the log of both sides. That's the only thing that's going to help you move forward on this question. None of the other tools or tips we talked about will work. So again, it can be the log of both sides or the natural log of both sides, whatever you prefer. I just like natural log. The reason why this strategy works is because it makes these two things exponents on something you're taking the log of. So that allows those exponents to come down out front. And sure, we've got a couple more steps before we're finished, but we're actually done with logarithm stuff now. Except, I don't know, natural log of e, you should really just change that to a 1. But otherwise, logarithm stuff is done.
Natural log of 2 is some weird decimal, but it's just a number. I can distribute this. And the only other thing to do is undo +1 with the -1. Making sure this just doesn't seem familiar with what I did earlier today, so I'm just making sure I brought this down to distribute x. Okay, yeah, that looks fine. It must have been a different question. And -1. That should be fine. But again, this is taking the log of both sides is not something I do often. But there are occasional questions where you can't do anything else. So that's a good last resort type of thing. Alright, you okay with that? Okay. Anybody else have something specific about 38 since it's a bit different? Okay, you got one or two more. Okay, I'll set one more timer. Today we've still got just under 20 minutes. So if I give you 10 more minutes to work, that'll give me about 10 minutes to finish up with your questions. Huh? You leave in 3 minutes? 4 minutes. Oh, my bad. Scratch that. I was looking at the ending time for fourth period. Ends at 25 after. Yeah, so we got to find a stopping place here. Again, you do not have to go home and finish this from homework, but if you feel like you fell behind where you think most other people are, then you might need to do a little bit of it for homework. When I see you on Friday, this is in A week, so I will see you again. I will give you some more time to work on this, and we'll also do a practice quiz for 3-3-3-4 to make sure that if something is off, you at least have a chance to get it corrected before we quiz it. So.